we're gonna start getting into exponents and getting into the stuff that I really, really like. This is where it all begins. Are you ready? It'll be fun. Here we go. All right. Product of powers property. We're jumping right in. Today, we are going to be focusing on multiplication properties of exponents. So you're going to see us build from, I say a low level, but it's going to feel hard right away. Or it's going to feel a little difficult right away, to a more advanced level by the third video. So we're going to be looking at the P lessons. And I say the P lessons because every single one has multiple P's in it. So this is the product of powers property. We're also going to be looking at the power of a power property and the power of a product property. Can you see those? 3 times fast, 10 times fast, whatever. It's like Peter Piper picked a peck of pickled peppers. Same thing, product of powers property. Ready? Let's go. Here we go. Product of powers property. This is where we're going to get started. Product of powers property tells us that the product, multiplication, of 2 powers, so 2 values with powers, 2 values with exponents, with the same base number in this one is 6, equals that base, so that's 6, raised to the sum of those powers. So essentially, what this whole thing is saying is if we have 2 numbers with the same base raised to an exponent, and the exponents don't have to be the same, just the bases. If they're multiplied together, we essentially can just add the powers, because this is really what happens. So this is why I tell everybody over and over and over, please write your stuff out in expanded form. So if I say 6 to the 7th, that's essentially me saying 6 times 6 times 6 times 6 times 6 times 6 times 6, 7 times 6 to the 4th, which is 6 times 6 times 6 times 6. All of these things are it's just a gigantic multiplication expression. I'm saying 6 times 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 6. All of that, I can just rewrite it as 6 however many times it's been multiplied. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 6 to the 7th power, or 6 to the 11th power. Okay, so if I expand it out, I can truly see that I'm just multiplying 6 over and over and over and over again, 11 total times. So now let's see this in action with a couple of problems so we can see how this builds on each other. I'm going to start pretty easy with this, and then I'm going to add in some of our properties that we technically have already learned when it comes to negative exponents, okay? So to start out with, 7 to the 8th power times 7 to the 4th power. I'm going to say it for the first few days. I suggest you expand this out to see it first to begin with. Technically, we can just look at this and say we have the same base. These bases are being multiplied. The exponents are then added. So I should get 7 to the 12th power. But to be sure, I can rewrite this in expanded form. So 7 to the 8th power is 7 times 8, or 8 times. 7 times 7 times 7 times 7 times 7 times 7. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. And then times 7 to the 4th. 7 times 7 times 7 times 7. That's a lot of 7s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I can just add those exponents together. So this is an easy version of what we're going to be looking at. Now I'm going to up the ante by adding in some other exponents. This time, I have m to the 3rd power times n to the negative 4th power times m to the 2nd power. I now don't have a base that's a number. Does that matter? No, it doesn't at all. I do have 2 bases that are the same, and they are multiplying each other. And there's an n to the negative 4th in the middle. And this n to the negative 4th, I know this is not simplified because this has a negative exponent. Negative exponents automatically tell me that this value is in the numerator when it should be in the denominator. So I'm going to deal with that in a moment. Let's first deal with these m's. When we have multiplication, we can move things around. We have all multiplication here. Same thing works with addition. I can move stuff around with the commutative property. We've looked at that before. So I can move this m to the third and the m squared next to each other. So they're right next to each other. M to the third times m to the second times n to the negative fourth. And I can rewrite it just like that. Okay? So m to the third times m squared. I can do that math based on what we just learned. Bases are the same, and they're multiplying each other. Therefore, I can add my exponents. So I should get m to the fifth for my exponent. But let's be sure by expanding it out. M to the third is m times m times m. M to the second is m times m. That's 1, 2, 3, 4, 5 m's. So I can rewrite this as m to the fifth times n to the negative fourth. I'm not finished because, again, I need to have all positive exponents, and I have a negative exponent here as of right now with the n to the negative fourth. So this m to the fifth has a positive exponent, so it's good where it's at. It's in the right place. So I can rewrite this as m to the fifth over n to the negative fourth can be put into the denominator and have a positive exponent now, because this is telling me that I'm essentially looking at this and saying, oh, well, this is m to the fifth times 1 over n to the fourth. This doesn't look complete. It's not simplified. So if I were to do this math, m to the fifth over 1, m to the fifth times 1 is m to the fifth. 1 times n to the fourth is n to the fourth. So here is my final answer to this monstrous thing, okay? M to the fifth over n to the fourth. I know I've happily confused you. Let me do it some more. It'll be fun. All right, here's our next one. Last practice. 3 to the negative 3 times 5 to the 8th times 3 to the 4th times 5 squared. Okay, big one, big one. Again, everything's being multiplied, so I can rearrange stuff. I can put the 3's and the 5's together. And so I'm going to do just that. 3's are going to get together. 5's are going to get together. And everything's just going to be multiplied in a new way. So I have 3 to the negative third times 3 to the fourth times 5 to the 8th times 5 squared. So we've been practicing it already before. We need to look at these and say, okay, what if I expanded them out to simplify them? This here is going to cause us a little bit of anxiety. The way that we can handle this first is we can expand it out, but what we can also do is we can guess what it's going to be. And it's not really going to be a guess because we know what this property tells us. This property tells us bases that are the same that are being multiplied, I add the exponent. So negative 3 plus 4 gets me 1. So this whole thing should simplify to 3 to the first power, okay? So let's just prove that to ourselves. 3 to the negative third is essentially 1 times 3, 1 over 3 times 3 times 3, just like that. 3 to the fourth power is 3 times 3 times 3 times 3. And I still have this 5 to the 8th, 5 to the 2nd. I'm not going to pay attention to that right now. I'm just going to simplify this here. This 3 times 3 times 3 times 3, technically every single one of those numbers is over 1. So if I were to simplify just this, I get 1 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 1. Again, I don't need to write the 1 because it's multiplying all of these 3's. It's not going to do anything, right? Ones don't, when you multiply by 1, nothing happens. So I have 3 times 3 times 3 times 3 over 3 times 3 times 3. So technically I have a bunch of extra 3's. So just by simplification, 3 times 3 times 3 times 3 is 81 over 27. 81 divided by 27 is 3. So to simplify this in a more progressive way, I can potentially take off the 3's on the top that sort of align with each other. So these 3's, they have a pair from the top and the bottom. These 3's have a pair from the top and the bottom. These 3's have a pair from the top and the bottom. All that's left without a pair is this 3. So I have 3 to the first power. Now I don't need to write through the first power, but I want you to be highly aware that every single base that is all by itself, if there's no exponent next to it, it has a first power to it every single time. Now let's do this 5 to the 8th times 5 squared. We know same base, add the exponents. So 5 is the base, 8 plus 2 equals 5 to the 10th. And actually, I don't want to write this because that's not actually equal. So 3 to the first times 5 to the 10th would be this massive thing simplified. So cool. All right, this was a really long video for our first video. I apologize. Hopefully they'll get a little shorter. If they don't, again, I apologize. 2 more videos in this lesson. You need to watch them both, okay? No exceptions. All right, bye.